Hello students, let us see today fixed point method. Solve e power x minus 3x equal to 0 by the method of fixed point iteration. So using fixed point method, now we are going to find the roots. So the given equation f of x equal to e power x minus 3x. So instead of x, we have to substitute 0. Then we'll get 1, so which is positive. Instead of x, we have to substitute 1. Then we'll get negative. So when you are substituting x equal to 0, you're getting positive. Next, when you are substituting x equal to 1, then we'll get negative. So therefore, a root lies between 0 and 1. 0 and 1. The given equation may be written as e power x minus 3x equal to 0. So e power x equal to 3x. This we will write x equal to e power x divided by 3. So which is g of x. So g of x equal to 1 by 3 e power x. So g dash of x equal to g dash of x means need to differentiate again with respect to x. So e power x differentiation e power x. So next modulus g dash of x equal to 1 by 3 e power x. So modulus g dash of 0 equal to, if we put x equal to 0, e power 0, 1. So we'll get 1 by 3. So which is less than 1. Next, instead of x, we have to substitute 1. Then we'll get 1 by 3e, so which is less than 1. So in the interval 0, comma 1, we get modulus g dash of x less than 1. So in this condition, very, very important. If it is satisfied, modulus g dash of x less than 1, then only we will apply fixed point method. So here, this condition satisfied. So fixed point method is applicable. So now we have to find out x naught value. That we are getting the roots here 0 and 1. So I'm between 0 to 1, I'm taking x naught value 0.6. Taking x naught value 0.6. So x1 equal to 1 by 3 e to the power x naught. So 1 by 3 e to the power x naught value 0.6. Using calculator, just to simplify, then we'll get 0.6074. Next is x2, 1 by 3 e to the power x1. So 1 by 3 e to the power x1 value 0.6074. Using calculator, just to simplify, then we'll get 0.6119. When the x values are repeated, until you have to do it. In case the x values are repeated, then we have to stop the process. So now x1 and x2 exact one decimal are repeated. So we can continue the process. So x3 equal to 1 by 3 e to the power x2 equal to x2 value 0.6119. This simplify will get 0.6146. Next to x4, 1 by 3 e to the power x3. So 1 by 3 e to the power x3 value 0.6146. The simplify will get 0.6163. Next to find out x5. So 1 by 3 e to the power x4. 1 by 3 e to the power 0.6163. The simplify will get 0.6174. So now actually correct two decimals are repeated. So we can continue the process. So next to find out x6. 1 by 3 e to the power x5. 1 by 3 e to the power x5 value 0.6174. 0.6180. Next to find out x7. 1 by 3 e to the power x6. So 1 by 3 e to the power x6 value 0.6180. So this simplify will get 0.6184. Now three decimals are repeated, x6 and x7. Exact three decimals are repeated. So just we will make one more iteration. Then we will get exact four decimals. So x8 equal to 1 by 3 e power x7. So 1 by 3 e power x7 value 0.6184. 0.6187. Next to find out x9. 1 by 3 e to the power x8. 1 by 3 e to the power x8 value 0.6187. 0.6188. Let's find out x10. 1 by 3 e power x9. So 1 by 3 e to the power x9 value 0.6188. 0.6189. Next x11. 1 by 3 e to the power x10. So 1 by 3 e to the power x10 value 0.6189. 0.6190. Next x12. 1 by 3 e to the power x0. 1 by 3 e to the power x11. x11 value 0.6190. The simplify will get 0.6190. So here x11 and x12 exact four decimals are repeated. So then we have to stop the process. So the better approximate root is 0.6190. So let us see one more problem in fixed point method. Cos x equal to 3x minus 1. So here given f of x equal to cos x minus 3x plus 1. We have to substitute x equal to 0. If we put x equal to 0, we'll get positive. So just 2. Next we can substitute x equal to 1. Then we'll get negative minus 1.45. So therefore a root lies between 0 and 1. The given equation may be written as x equal to 1 by 3, 1 plus cos x. So it is equal to g of x. So g of x equal to 1 by 3, 1 plus cos x. G dash of x equal to 1 by 3. Again here there is no x, 0. Cos x differentiation minus sin x. So modulus g dash of x value 1 by 3 sin x. So we'll check the condition. Modulus g dash of 0 equal to 0, which is less than 1. Next we'll check modulus g dash of 1 equal to 1 by 3 sin 1. So this using calculators to find out the values. So which is 0.2804, which is less than 1. So modulus g dash of x less than 1. This condition satisfied. So fixed point method is applicable. Okay, here therefore a root lies between 0 and 1. So I am taking here x naught 0.6, x naught 0.6. So x1 equal to 1 by 3, 1 plus cos x naught. So 1 by 3, 1 plus cos x naught value 0.6. Using calculator, simplify this, then we'll get the x1 value 0.60845. Similarly, should find out x2, x3 value. So x2 answer 0.60684, x3 value 0.60715. Next to x4 value 0.60709. So now correct to 3 decimals are repeated. So you can continue the process. So x5 value 0.60710. So x6 value 0.60710. So exact 5 decimals are repeated. Hence the better approximate root is 0.60710. So given any problem in fixed point method, so first you should write the given f of x. Next we have to substitute x equal to 0, 1, 2 like that. So you should find out the roots. For example, the first problem, when you are substituting x 0, we are getting positive value. If you are substituting x equal to 1, we are getting negative value. So therefore a root lies between 0 and 1. Next you should make x, so which is g of x. Next you should differentiate with respect to x, so g dash of x. Actually here modulus g dash of x less than 1, this is this sufficient condition. In case if it is satisfied this condition, then only we'll apply for fixed point method. The first problem satisfied for the condition, so that's why we are applying here fixed point method. So here x11 and 12 exact 4 decimals are repeated, so hence the root is 0.6190. Similarly, you can solve the second problem, then we'll get the answer 0.60710. Thank you, students.